Yeah, welcome to our working group. This is open sharing working group, uh, which we uh, we discuss about open science, research data management, something like that. Can you hear my voice
Yes, yes,
clearly?
clearly. Now clear.
Don't I don't think what to say.
Well, it's
So please.
yes, welcome everybody. It's okay. Marcus, as a co-chair, would you like to welcome everybody as well?
Look, I'm just very happy to see a good audience, and I'm very disappointed I was unable to join in person due to family issues. But I think our time is limited, and we have a large number of very good speakers coming. So, Joe, take it away. I think.
Okay. Yeah. We have many speakers, so we'll start with Yoti, I think. Share your slide. Actually, because many
Yes.
people we say you have 30 minutes, I would say 25.
Is my screen visible to everyone?
Yes.
So, a very good morning to everyone. My name is Jyoti Bhogal. I am based in India, and today I am going to be speaking about what is research software and why should we think about its sustainability. So, I'm Jyoti Bhogal. I am the lead and co-founder for RSE Asia Association, which is Research Software Engineering Asia Association. I've also worked as a software quality assurance engineer for clinical trial development optimization, and I have a background in statistics. A little more about me: I have previously worked at Citel, which is a software development organization. It's a contract research organization, and I worked there as a software quality engineer by using various tools like R software, Excel, to create test cases and test the quality of the software which was being created for clinical trial development. I've also worked at Deloitte as a consulting analyst for clinical research data management, and I've also co-founded Research Software Engineering Asia Association, and I'm an active part of different communities like the Open Life Science, where I was a mentee at cohort 4 and cohort 5, and I also co-chair RSEAA 2024 Unconference, which is the RSE Asia Australia. I'm also part of the R Ladies Global Community, which is a global community for the R language. So, starting right off, so what is not a research software? A research software, as per the definition developed by FAIR for Research Software Working Group in 2021, research software includes all the source code files, algorithms, scripts, computational workflows, and executables that were created during the research process or for research purpose. What is not a research software is all the software components, for example, the operating systems, libraries, dependencies, packages, scripts, etc., that are used for research but are not created during research or with an intent for research development. So, who creates research software and where is it created? It is created during or for research by researchers and scientists. It is also created by citizen scientists, independent researchers, industry laboratories, academic research labs, open source maintainers and volunteers, and many more. What is the use of research software? So, it is useful to automate different software development tasks, for creating new algorithms, and for verifying theoretical results computationally. How do we store research software? So, there are various platforms like Zenodo, GitHub, and GitLab which can be used for storing research software and then reusing it multiple times as and when required. There are certain good practices which must be followed while writing and storing research software. First of which is storing the files with informative names. So the file name should be such that if the file name is read, it gives an indication of what is contained inside the what sort of code is present inside the file. It should also use within the code, whenever we are defining variables, the names of the variables should be informative, and they shouldn't be random names like A, B, C, or XY. They should be informative and descriptive of what they are used for computing. The code should also be documented so that when one person has written the code and someone wants to access it, understand it, they can refer to the documentation. And one of the best practices for documentation is to write comments in the code itself rather than creating separate files, which would make it more complex. Some of the version control systems exist, which help in reusing the software and also to access the version which has been created some time back. So some of these are GitHub and Bitbucket. Now moving towards the reproducibility of research software. So why do we need the software to be reproducible, and what are the benefits of doing so? So when a software is made reproducible, it helps in verifying research results, also helps in collaboration in wider scientific community. It reduces the time spent for reinventing the wheel, and it is helpful to be able to modify a code to customize it for different settings. So reproducibility helps in tracking project history, collaborating and reviewing. It avoids misinformation. It helps in writing a paper efficiently. It also helps in getting credits fairly and ensures continuity of the software. Any research software should be licensed. So in a research software code, there are two components. One is non-code and one is the code component. For non-code components like documentation and images, it's a good idea to use the Creative Commons license. Whereas for the code part, it's a good idea to use the open source initiative approved licenses. Some of the different license types are copyleft, permissive, Creative Commons, and public domain. So, who is a research software engineer? This is a broad term which is used for people who combine programming skills with research skills that have trouble defining their role and value within academia. Some examples are researchers and academics who code, generalists who bring communities together across the research and technical domains, systems administrators who maintain research systems, and software engineers who work in research domain. So what is the RSE movement? The RSE movement began at the collaborations workshop event conducted by Software Sustainability Institute at Queen's College, Oxford in March 2012. A small group of people met to discuss the lack of careers for software developers in academia, and that meeting led to this wider campaign called as the RSE. So the new role that emerged out of it was called the Research Software Engineer, or RSE. So far, till 2021, research software community was widespread in areas like UK, US, Australia, and some parts of Africa. However, it was missing in Asia, and that's where we came up with RSC Asia Association, and in collaboration with the international RSC community. What we have brought to the table is that we have brought diversity, and we are aiming to achieve a global recognition for the um, uh, people who are either directly or indirectly working on research software within the Asian region. The RSC Asia Association was launched through the OLS 4 program, the Open Life Science 4 program, as part of a project conducted during one of the cohorts of the same in 2021, where OLS or Open Life Science became our mentor organization, and our project mentor was Dr. Anne Forlocks, and so Saranjeet and I, Jyoti, we both were the project leads in the same. The journey continued through OLS 5, which is Open Life Science Cohort 5, where we build pathways for onboarding research software engineers in Asia, and adopting a code of conduct for the community. This is a bit of a design of how the Open Life Science program works. So they have a series of meetings, so alternative mentor-mentee meetings, along with meeting the cohort throughout the course of time. People develop their projects with the help of guidance from mentors and the uh, others fellows in the cohort, and there are tutorials as well for people who have joined newly. There are GitHub tutorials. There are sessions on leadership and also a session on self-care. Speaking a little more about the Research Software Engineering Asia Association, the mission is to promote and build the research software engineering community and profession in the Asian region, while also fostering global collaborations. I'll like to speak a little about the activities that we have been doing at the RSC Asia Association. So we constantly maintain our website, and you can access it via research RSC Asia Association GitHub .io. facebook.com/rsc_asia. We participated in Hacktoberfest 2021 at the launch event. This was an online event where we called in people to launch the association and also got their help to contribute towards the open source software that we are developing. We also organized a workshop on learn how to write alt text for images and diagrams. So this was a software that we conducted in July 2022, where we called Mars Lee to help us in writing, guiding us how to write alt text for scientific diagrams. We have also been conducting consistently annual unconferences, which is the RSE Asia Australia Unconference. We have successfully completed the first and second edition in 2022 and 2023, and this year around we will be having the unconference from September 10 to 13, and anyone who wants to know more about research software engineering is more than welcome to register themselves for the unconference, and the link is given over here. So you can go to rscaa.org and register yourself for the unconference. It is going to be entirely online, and it would consist of various keynote sessions as well as panel discussions. We had also participated in Hacktoberfest 2022 for the whole month of October 2022, where we got people to contribute to the RSC Asia Association website. There are some more activities that are happening in future at RSC Asia Association. So we will be conducting a series on a monthly discussion series on open science and research software and how they overlap. Another upcoming event is the third RSC Asia Australia Unconference happening from 11 to 13 September, which you can register for. So now, speaking about some of the programs for research software, for developing your career in research software. So there are various mentoring, training programs, and for open source development and open science. Some of these are Open Seeds by OLS, through which we had launched RSC Asia Association. There is Google Summer of Code, where one can contribute in open source software, and it also has Google Season of Docs, where the focus is more on documentation for open source materials. There is also research software camps, which is run by Software Sustainability Institute. And if you check out the website of Software Sustainability Institute, you will get to know more about programs and events associated with research software. There are certain communities of practice and organizations that focus a lot on open source and open source software development. Some of these are Open Life Science, the Turing Way, RSC Asia Association, Society of Research Software Engineering, and Software Sustainability Institute. Now, to engage you all and to see what all you have learned through this talk, I have created this activity for you. You can scan the code to participate in it, and it's a quick Google form where you can share your thoughts about what research software is, what you have learned through this session or from your previous knowledge about research software. And then it also has, so there are 3 questions in this form. You can please scan this code, or if it's not available, I'll also share the link for the same. And you can tell us about what you think about research software engineering, and also if you would like to be, if you would like your thoughts, we would be mentioning these on our website. And if you like, you can choose your name to be mentioned on the website, or you can also prefer to be anonymous. You can share this through the Google form itself. Please let me know if you are able to scan the code. If not, I'll also share the link in the chat. So people in the live audience, they can scan the code, or those who are joining remotely, they can join, they can access the link from the Zoom chat. I'll also share this on the VOA app, where everyone is, where I expect more people to be present. So I'd like you to take a couple of minutes to give your responses to the Google form.
Yes, thank you. Then from NII, the second speaker, second speaker, Masaharu Hayashi. Would you please share your screen?
So we're gonna update from Japan and followed by the Korea and China. So this is what we wanted to do in this, the working group session every single year, twice a year. So listening to even the small part, the update from each individual countries, and then try to figure it out. The things we can connect or collaborate each other. And of course, research and engineering software is also so important. So we can merge this kind of, the global activity, and then maybe, look for the glue or, the connecting point between us. But anyway, Masaharu, so your screen is something weird. And the next slide. So as you may know, my next slide. I said next slide. My research center, the Center for Open Science and Data Platform, is one of the research center in the NII. And NII is the Japanese NLN. And of course, basically we are providing the high-speed network. And my research center has a mission to provide the data platform on the top of the high-speed network. And the next go. So the research center is now developing the so-called NII Research Data Cloud, which composed by the three main components like this: RDM platform, publication platform, and a discovery platform, along with the research data lifecycle. And today, we're gonna introduce a bit more in detail what's happening around the publication platform, of course, including the new topic about our cloud service for the institution repository. So Masaharu is a leader of this publication platform project, and then he's gonna introduce the recent update about our the cloud service functionalities. Oh, there is. So maybe so as you can see from this slide, so we are providing the cloud service for the institutional repository named Gile Cloud. And as you can see from the left-hand side graph, so orange part is the number of the university which employed our cloud service, meaning that if I compare with the total number of the institution repository in Japan, it's more than 800 or almost close to the 900. The most of the institution is now using our cloud service, and not only just by handling a open access article, but also right now the Masaharu is now developing the system under the collaboration with the Cern Invenio guys, and then providing the new functionality for handling the research data as well. But today's talk is much more focusing on the open access, and I'll let you know about which kind of new functionality we are right now developing for accelerating the open access activity in Japan. Masaharu, please let's go.
Now let's may talk about the green open access situation in Japan. Currently, more than 800 libraries operate IR in Japan. This graph shows the breakdown of item types stored by Japanese institutional repositories. This graph shows a journal article is 13% of the total, and the green open access is not as advanced as would expect. In Japan, green open access generally means archive-style open access for libraries. Archive-style open access is an open access concept which requires its libraries to open all institutional items, regardless of status of items. On the other hand, open access mandates force researchers and institutions to respond to green open access or gold open access. Unfortunately, archive-style open access is not working all institutions now. Of the more than 800 libraries, only a dozen or so are actively involved in green open access. To improve this situation, we first need to find the cause of the situation. We think the cause is the shared concept of archive-style open access. This concept is straightforward, but it is problematic at the same time because the burden it will bring makes libraries reluctant to practice it. Next, let me propose a concept which might be able to replace archive-style OA. Concept we want to propose is pragmatic OA, which requires libraries to open only important institutional items. Important items are supposed to be not open access items. In addition, funded or fast authored items can be important in some situations. By focusing on only these important items, the burden on libraries will be reduced. Filtering and registering only important institutions items is more practical, but it requires significant preparation cost. Once concept is replaced, workflow is supposed to be replaced as well. Archive-style open access aims to open all institutional items regardless of their status. Its workflow doesn't have a status check. This means no items are filtered before processing. On the other hand, pragmatic OA workflow should have status check such as open access check, fund check, fast author check. This means many items are filtered before processing. So burden to open items are reduced. But the workflow becomes a more complex and more costly tasks with status check. So we have started developing this kind of system to semi-automated workflow. Basically, this system sends you metadata newly publication institution item every week. It also sends you OS status, fund status, fast author status of each item. So items can be filtered by using these information. In addition, it sends you policy page URL of each item. If our policy database has information, and OA progress is displayed on dashboard. This system covers most of workflow, including status check. Also, the system will do all the preparation for filtering, which is the most important part of the pragmatic OA. So the workflow complexity and the cost tasks will not be a problem with this system. But only full text request isn't covered because we don't have researcher email address now. This system is still under development, but we used it to check how programmatic OA works. To check now it works, we examined changes in the number of items. We used the University of Tokyo as query and got 160 newly published items in 1 week. And we found items are reduced to about 50% per status check, 13 after all 3 status check. We think these numbers are small enough for many libraries. This system reduced time and effort to gather filter information for selection and realize pragmatic open access. This slide shows some of user interface images. Information about the newly published items is displayed item by item like this, and open access progress is displayed on dashboard like this. This is my final slide. The open access mandate is coming. Farm library and OA support is important for a few years. Programmatic OA and OASIS system powerfully help OA workflow support for librarians. The dashboard feature is important for managing an institutional OA progress. However, a shift from library-driven to researcher-driven is required when the OA mandate goes into overdrive. In future plan, integration with the research data management infrastructure. Our service name is Gakuni Alden. This service, a researcher-centric system, is the next challenge. Thank you for your attention.
Thank you very much. We move on to next speaker from Korea.
Thank you, everyone. Good afternoon and good morning, everyone. I am Sa Kwang-song from Research Data Sharing Center at KISTI in Korea. This time, I'm going to talk about Korea Research Data Commons for research software sharing and utilization. In the previous slide, Jyoti introduced about research data sharing and other activities. So I understand most of you understand what it is, and so it will be helpful to understand our system. Before getting to the detailed part of my presentation, I'm going to talk about a little bit about the KISTI's open science activities. There are actually three main open science activity. First one is Access On, and second one is Data On. The last one is Science On. As the name says, Access On is related to open access. So it provides, from authoring to disseminating open access articles. It provides discovery, self-archiving, monitoring, and co-authoring services in Korea. And the second one is Data On, which is developed by our center, and is mainly focusing on research data. So it's a kind of a national research data sharing platform, including research software sharing environment. It provides registration, interconnection with other, institutional data repository or other platforms, and it provides discovery and analysis services. The last one is Science On. Science On is a kind of portal service of open science in KISTI. So it provides integrated search based on Access On and Data On. In addition to these two services, it also interconnected with other various kind of KISTI services like NTIS, KMAPS, Compass, COSAN, and so on. So it wants to be a real, portal representing KISTI for open science. As you can see in the right side of the slide, there are three rectangles here: Science On, Access On, and Data On. At the bottom of it, you can see the several kind of computing resources like supercomputer, cloud, research network, and so on. Now I'm going to talk more about Data On service. This is the conceptual diagram of Data On. Data On is a Korea research data platform, which is focusing on managing and utilizing the research data in Korea. So it provides several kind of services and is interconnected with other various kind of platform. For example, domain-specific research data platform or institutional data repositories and so on. So we already have more than 20, those kind of platform or repositories. And it also interconnected with other global open research data or open science platform like OpenAir or ARDC, ARCOS in AIA. So Data On has several kind of services, including registration or preservation and discovery services for research data. Also provide repository registration and interconnection with other research data platform. In addition to this kind of research data related services or functions, we also provide a software development environment, providing virtual machines, Jupyter Lab, and GI-based workflow. It has more than 1.3 million metadata. Actually, but most of them are from the other, platform or repositories. Only 40,000 metadata from in Korea, and almost 5.6 million of figures and tables are provided in this platform. Data On actually is a research data platform, but we also provide a tightly coupled, software sharing platform, so-called Data On Canvas. Data On Canvas provides Jupyter Lab, to provide users with software development environment. And it also provides the easy development environment based on GUI-based workflow modeling and analysis tool. Currently, we provide 129 apps and workflows. As you can see in the right side of a slide, it shows workflow web UI. There are, square in the middle, which means apps, and apps can be interconnected with each other, like using mouse activity, mouse motion. And it has several kind of key features. It is built on top of Kubernetes Cloud, and it has templates provision for easy software app development. Usually, app developer, it's not easy to develop this kind of app for predefined, system like data on canvas. So we provide several templates, which we hope the developers can easily develop their own, softwares. And it also provides a drag and drop style workflow modeling, as I told you. But this data on canvas is tightly coupled with data on system. So there's several issues here. It's not easy to extend this system to other, organization or other system. And it does not support multi-cluster, and it's not easy to install or configure to other systems because it's tightly coupled to data on. So the internal systems are very tightly coupled, and they are very highly correlated with each other. So this is the conceptual diagram of data on, the current situation of data on. So as I told you, that data on is a kind of aggregation service, and is interconnected with other research data platform or institutional data repositories. You can see bottom of the figures. There are several kind of domain research data platform, and some organizational research data repositories can be interconnected with each other. So the metadata of data set from each organizations can be aggregated, and the data provide integrated search to the users. But as time goes on, most of the research data platform or organizations having IDR systems are trying to build their own, utilization software data set. So they want their own, cluster and software utilization systems and so on. So, but based on this data mechanism, it's not easy to gather such kind of metadata for computing resources, including software, virtual machine, hardware, and so on. So the problem is this kind of concept is difficult to find, share, and utilize computing resources across organizations. So we add this kind of KRDC concept in addition to data on. In the right side of the screen, you can see the KRDC part added to the previous slide. The KRDC concept is to gather resource metadata. For example, software or virtual machine or other resources have their own metadata. So we want to gather those kind of metadata from the domain research data platform or institutional repositories, which has their own computing resources. So the red lines are means that the gathering the metadata from those kind of resource metadata from other distributed organizations. Now then, what is the KRDC means in in the former way. KRDC is a concept for utilizing both research data and computing resources to maximize the sharing and utilization of national research data based on data on. Simply speaking, KRDC is a joint utilization system of research data and computing resources. There could be some kind of confusion between data on and KRDC. Actually, data on is a system that provides various functions for sharing and utilization research data. However, the KRDC is a concept, and which is logically federating various diverse research data and computing resources system. So it's a little bit different between the concept and the system. But actually, we will plan to extend data on by employing this kind of this concept to keep pace with global research commons activities, such as Global Open Research Commons, Global Open Science Cloud, EOSC, ARDC, and so on. This concept in order to implement the this concept, we built the this platform. this platform consists of this Hub, this framework, and storage services. Its goal is to achieve fair needs of computing resources eventually. The first component, this Hub, is only one service existed in a this platform, which will be integrated into data on web service later. And it provides metadata search for apps and workflows aggregated from all connected, this frameworks. The core part of this platform is this framework. this framework is built on top of Kubernetes clusters. Kubernetes is also known as de facto standard of cluster operating system. So it's very important and popular, open source software. So we built on top of Kubernetes cluster, and this framework provides Kubernetes KRD's framework web services, which provides metadata search for app and workflows in KRD's framework and KRD's Hub at the same time, and also provide fast search by category, app type, access type, and so on. Actually provides virtual machines, Jupyter Lab, workflow environment, as the data on does, but a little bit different from the data on and KRD's framework. I'll talk about it later. And the last component is storage service. Storage service, as the name said, is a storage service for private and public data volume in a KRD's framework, and also provide repositories for app image, application image, and source codes. KRD's framework, as I told you, is the core part of KRD's concept. It will be a part of extended data and distributed free of charge to other institutions in Korea once we built our KRD version 1. The goal of this KRD framework is to interconnect research data and software platform of government-funded research institutions in Korea. There are several kind of domain-specific research data platform already developed or currently developing, like materials platform, biology platform, aerospace, future experimental data, and so on. And also, we also want to interconnect it with other, government-funded research institutes like KIGAM, KIOM, KIOST, and so on. And we want to, using this KRD framework, we want to share computing resources as well as research data. Currently, we are focusing on the research software because, it's much harder than other computing resources like, virtual machines or web services and so on. And eventually achieve the fair needs of research software based on this KRD framework. It will be distributed to other institutions. So if most of the institutions are using this kind of framework, then it's we hope that the integration between institutions are much easier than. So the first version, alpha version of KRDC framework was developed in 2023, and currently we are developing the next version, beta, and we hope that it will be stabilized by the end of 2024. This is the conceptual diagram of KRDC platform, but you can see the name of open source software. KRDC platform uses almost all of the open source software, but based on open source software, we added some kind of developed our own module of softwares. But actually, you can see very famous open source software inside the box. For example, storage service, we use MinIO and SAP storage services, and Keycloak, Istio, Grafana, Jitkin, and so on. You can see here, on top of the screen, there are KRDC Hub cluster. It's the only one in a platform, and the left bottom, you can see many of Kubernetes clusters. Here, on top of Kubernetes clusters, KRDC framework clusters are installed. So it could be several, one or more, KRDC framework. And the right side, you can see the storage services. It can be one or more. Are described as some of the main, open source software for authentication, authorization. We use, Keycloak, container orchestration, Kubernetes and Docker, service mesh, database and storage services, and so on. I'm going to summarize this talk. KISTI has been prepared for open science promotion in KISTI in Korea with 6-year program since 2021 to 2026. Currently, we are developing the beta version of KRDC framework, and it will be shared with other institutions. And at the end of this year, it is scheduled to install our KRDC version to the KIGAM, one of the government-funded research institution in Korea. And we also have ongoing collaborative project with EGI in Europe in order to interconnect with KRDC and the EGI Commons. But the problem is that there is no separated regulation for research data except DMP in Korea. So we have been trying to make a new bill for this kind of research data or open science and so on. But every time it's not easy to fix it. But we are supporting the Ministry of Science and ICT that the new bill will be settled next year. Then our research data management and research software management policy will be more progressive. This is the end of my presentation.
If I understanding correctly, this KLDC federate a distributed computing resources, including high performance computing in Korea.
Yes.
So, but before coming the KRDC, each computing center or high performance computing center has its own registration system and a charging model, I guess. So I thought, that KRDC also has to think about, just thinking about, the federated service in terms of the, the technical aspect, but also you have to think about more, the policy level or operational model, or, how to charge from the end users. So which kind of, the system or regulation or something you has in addition to this KRDC federated computing resources system?
Thank you for your excellent question about this KRDC related issues. Actually, it's very hard to solve issues, especially charging and then the policy, something like that. Mm-hmm. Because it's just the beginning stage of developing this kind of, sharing computing resources framework. In the previous, there are a lot of separated computing resources or clusters, supercomputers, and so on. So it's not easy to integrate and have one, one fiscal policy to apply those kind of, different computing resources. So in this topic, KRDC, we are focusing on the research data management systems. So you know that in Korea, many institutions are trying to gather research data, and at the same time, they want to build their own utilization system or clusters to support users with utilize or share their research data. So we are focusing on that part. Research data platform or institutional research repository also have their own research, computing resources like clusters. So we want to help them to build their own computing resources, including virtual machine, Jupyter Lab, or workflow management, and so on. Then we can share with each other based on that framework. We are not trying to integrate other types of clusters or supercomputers. We can just redirect or loosely couple interconnection between those kind of resources like supercomputer or other types of clusters. They already have their own policy and their rules or system integrations method and so on. So we also can interconnect with those kind of systems. Actually, the EOSC, European Open Science Cloud, currently doing like that, just linking with each other. Yeah. Not tightly coupled with each other. Just have their own linking systems or have landing URL and so on. Just interconnect with a single sign-on, like AAI. So, but we want to overcome this kind of bottleneck. Using this kind of KRDC framework. That's our purpose. But this is the starting stage, I think. So we think we need more time to promote this kind of culture in Korea.
Okay, thank you so much.
Okay, Mati, you have a question, please. Mati
Yes.
from RDA, he will be the speaker for the second session. Please.
Okay, thank you. Yeah, I work with the RDA Europe and actually also have been involved with the EOSC activities for quite a while. And I got curious because the title mentioned Research Commons, and I went into the Global Open Research Commons group at the RDA, and I noticed that you're a member. So I was wondering if, to what degree there is sort of interplay in a way, because of course my understanding of the GORC is that it's much higher level model, sort of abstract, but do you see sort of similarities or benefits? Is for example what you're working on one of the case studies in the interest group?
Yeah, actually we are working at the those kind of working group, Global Open Science Cloud and GORC. And we already present our idea and current status at the working group. So we're also very interested in such kind of global activities in RDA, and we're also trying to contribute our experience with them. But still, we are mainly focusing on the internal domestic situation. Rather than the other, global situation. But we're also trying to follow or aligning their model. You know that the Gork model, the version 1.1 is already ongoing, published, right? Okay, so we also interested in those kind of international model, and if possible, we are trying to apply those kind of ideas to our system, and it will be much interoperable with other commons. So, but for now, we are mainly focusing on the domestic situation rather than the international activities.
So yeah, in the short term, you need to have a running system and provide services. But then, I mean, from RDA perspective, it's very interesting in a way that let's say something like the Gork framework is there at least some kind of reference document, and I think this is something that I will report back to my colleagues, and I would also love to hear more about, let's say, possibilities of having a case study and so on. So thank you.
Yes, thank you.
So the next speaker, Yun Cheng from the, we'll talk about open science practice of CNIC, CAS infrastructure and information services supporting resource sharing and public engagement. The floor is yours.
Thank you. Show my presentation. So getting started from here, like the open science infrastructures ABC, that's UNESCO recommendation, and this is about our center. We are the birthplace of China's internet, and now we support APAN Beijing office, and also with CERNITE, we support APAN China together. The main purpose is to secure the internet connectivity among the centers. And also we built the high-speed network, and we also upgraded our international connectivity, not as high-speed like the network operated by NII, but we have we are according to the evaluation of the administration here in China, we are on the top. We are on the top about this service in China. And here is the recommendation D. It's something related to this. I think this is something also related to the question to Kirsty. That's we have the supercomputing services like the computing facilities. And in this morning, we have discussion organized, our center support the organization of discussion among the experts in this field in China. And actually their concern is very similar to, I think, to the question to Kirsty, is they have different charging modules. And although many experts has realized that it's good to share the resource together, and but is pretty difficult to it is at the very beginning is still they have different standards and different funding models, different evaluation standards. But people get started to discuss about how to connect those computing resources here in China, scientific computing resources. And this one is, so our team support the computing facility service of the Chinese Academy of Sciences. Based on, now we are discussing about software, a lot about the software development, because traditional here in China, there are a lot of investments on hardware, but the software environment compared with other countries like the US is, the ratio is very low. So people are working together and try to produce some type of policy recommendation for decision makers, and hope that more resources could be invested related to the software development, as Jyoti just mentioned, that's very important. So there are a lot of ongoing discussions here. So CNIC team, we work with the research teams here of the Chinese Academy of Sciences. These are some of the software solutions that our team developed with the scientists here. And this one, I think one of the challenges my colleagues and our partners feel is the challenge of AI, because it's different. Some of the questions are different from traditional computing tasks. So what they do is they are trying to build some type is called AI large-scale computing platform, which is also based on some of the computing resources, and also have some resources acquired from CNGI, which is an effort here in China to connect the computing resources together and for scientific computing. But it is not a type of infrastructure like the electricity. Is still at the very beginning, and it doesn't have those type of regular funding sources for it. Is like the bottom-up activities among the computing centers is based on this, and my colleagues and other experts are working together for some combine it with some of the new questions of AI to support different research domains here. And the next one is about this. This is about, we also support the building of the CAS scientific system, and including the data management and also some of the methodology. By that, we mean that the standards for CAS data centers as a recommendation, and also the system means that because the general data center of the Chinese Academy of Sciences is located in our center, and we mainly support the cooperation, build some type of software stack to support the cooperation among those data centers, and also some type of integration. We have a lot of services together. Like this one. We also support the Secretariat of CoData. I think many experts perhaps here are familiar with this international organization. And this is the CAS Data Cloud, and the visit to the National Basic Data Center. That's one of the national data center supported by most, the Ministry of Science and Technology, and our center, our center host is the only data center across domains, and around 1/3 of the key research projects here in China submit their need to submit their data report to them, and some resources, share some resources for them. But the main challenge is many of the scientists are fully occupied, especially those PIs participating in those research projects. So we can say like a Maker Data Fair, or but sometimes they don't have time, but so our teams works a lot with them to provide the support, also to provide some type of tools to make those type of data submission as simple as possible. And this is something is called big flow. That's a type of solution, because our center not only support the data service of the Chinese Academy of Sciences, also the network community facility and the data tools. So we try to combine them together to support, because many of the research questions, they are when scientists work together, they need data from different scientific data centers. And so this big flow is if they have some questions, you have the research questions here, and different scientific data centers want to work together. this system to help them. We call it like the end-to-end solution is different data centers can use their data to work together and for usually interdisciplinary questions related to socioeconomic development. And that Deva Kisti has mentioned they have cooperation with our center. Actually, also Huawei has a cooperation with our center with this. This is called the China Science and Technology Cloud is infrastructure that our center want to combine all of our resources together to support scientific discovery. And we also work very hard with partners, NII and KST. We had regular discussion recently. We also work with EOSC and OSP. EOSC, those EOSC, we worked with EJI. I think many of you are familiar with EJI and OSP. We worked with our team build some type of connection with them of the AOSP, but not one of the 3 AOSP nodes just this year during the New Year celebration. And the reason is because they are the AOSP is doing something like to support to have those resources to connect together to support like some of the future research like related to some big corporation like SKA, and because CAS is also very active in those type of big corporations, so that's why we are going there. And this is GEOSC. Kirsty colleague just mentioned that we also participated in the GEOSC Corporation, the Global Open Science Cloud, and these are something our center just got the approval from nation to build the next generation integrated e-infrastructure for science, which we will try in the next 5 years. We will try to combine some of the resources here, but of the Chinese Academy of Sciences, but is because open science is community driven. So the intention of the scientists of the research team is also very important for those type of efforts. And something special about CAS is CAS also hosts a lot of field stations and key research infrastructures, and those are the sources for big data, especially the key research infrastructures. But as I mentioned, we'll need to get some type of agreement with those type of key infrastructures, and to discuss about as open as possible and as close as when it is necessary. So we are my colleagues has a lot of discussions with them. Actually, also the training seminars every week. And the Cloud Federation, and as Kizzy also mentioned, this type of idea of the cooperation, and we hope in the future we could also make some contributions to the share of the resources based on this, and is still a prototype at the very beginning, and we are working closely with the OSC and KST, and we hope NII and also the Africa Open Science platform, all the colleagues and interested in this type of resource sharing in the next 5 to 10 years. And this one, I think a lot of colleagues has mentioned NII and Kirsty all mentioned about it, is about linking the publications and data and data repository, those different resources together and make them as fair as possible to support not only the scientific research, but also other activities meaningful and for the civil society. So this scientific data bank is also operated by our center. This is many of the academic journals here in China. They submit their data to the Science Data Bank, and Science Data Bank is connected with CSTR, the API and badges. Those type of services are supported by the CSTR identification team, and they are working together to help the research teams find the data and use them for the reusability for those type of services. And our center also has a journal. It's called the China Scientific Data, and that journal published. They are trying to publish some data papers. Is not just related to submission of data, but also some type of articles that explain how those data are produced and used for scientific research, because we think it's very important to make people know, and especially like people talking about AI or talking about of the connection of computing resources, but data is very important, especially the quality of data. So we think is very important for people know the value about it and also get some credit from it. So we are trying to combine all of resources together for supporting that, including the identifier service at the Science Data Bank, like the data repositories and the data journals. Those data are submitted to the data journals, and also the data journal itself. I try to link them together to support that type of thing for free. Those are free services. And some of the capacity building activities and also discussions related to open science at our center in last year and this year. And this will also have a lot of local activities here in China, and work very closely with the open science practitioners here of CAS, not just scientists, but also the IT engineers supporting those type of activities in research institutions of the Chinese Academy of Sciences, because scientists are usually fully occupied. We think those like the IT people will be very important for supporting those type of activities. That's why we hold those type of local training activities. And this something about related to citizen science is not published yet, but our data visualization team, they are trying very hard to build some citizen science protocols like this one. This is about you need to select the site for some of the stations, and those are related to different data, like the bird migration and also the location, and also the climate. So we are trying to build some system based on our data visualization capability. And in the future, we want to share it not only with the research team, but also the public. This type of tool, we think, have the potential to build those type of digital literacy, not just for is related to research, but more than that. And this one, because open science is also related to open educational resources, and the science communication, our teams also support CAS for the science communication, including the CAS websites, not just the headquarters, but also we build the website system for CAS institutions to build their websites. Those that is related to science communication and public outreach. Our team support the release of 70% of public outreach contents of CAS research teams, and they also support a lot of activities of the Chinese Academy of Sciences, like the public open day, like the science festival. So we are try to share that resources to as many people as possible. So those will after all those activities, will share the resources online. So more people could visit the resources. The professional open training, we mean the professional training, because we build the professional training is called continual training portal of the Chinese Academy of Sciences. We also have those curriculum, those type of resources. And now we get started in order to help the research communities here in China to stay connected with the international community. We get started to share some of the resources, especially their cooperation with the international community, and build some outreach contents based on that. It's called Science Ape. I think you can find it. Those are some activities of center hold with the institutions and local schools and together. So we, I think we are really interested in to get more people involved in open science, including some from the civil society. And this one is not related to open science, but I want to share this with you because this one, we support the day-to-day management of the Chinese Academy of Sciences, including its research institutions. And you can see we have CAS has a lot of cooperation with the outside world, and also the members of those countries related to APAN. So that's why we are here. We want to share our ideas with you. Thank you. Thank you for your attention.
Thank you very much, Yushin. Any question? No, but I have question for Taka-san. From what we are hearing, we have so many open data and then open information that can we add or update this to the APAN data, the website, I mean the web portal that NII is taking care of?
Okay, yeah, I will update the APAN data and add the information about this APAN session.
Right. The information of this, and then everything
need...
that they can share. So just can expand that in the portal. Can we do that?
Yeah, we can do that, Chai. But before doing that, maybe it's better to talk, our direction or the main concept, how to extend or expand our site. Okay. So maybe it's better, and there's no time, good enough time to discuss about today. So maybe we're gonna have, the webinar or not the webinar, teleconference after this APA meeting, and then let's think about it.
Okay, we can have a follow-up meeting as a
Yeah. That's right.
schedule that up. But we have two more questions. Okay, all live first. Marcus, please, and then here the ladies.
These questions generally from all the speakers who are working on the data resource, because I am not from the computer or the electronics field, I am from the education or the research field. But as the research is going on, we are mostly seeing that the data is getting piled up. And now in the research, what we require, the latest data and something. So I just want to have a one query that what is the policy in your data sets that the data that is getting obsolete or the very old, either it is stored there or it is something like that that will not be available. Because for the research, mostly we are having the latest 1 decade data or the 2 decade data like this. Second question I want to ask that sometimes the clients, not the commercial clients, the end user client, they may have certain queries that they want data in a very specific manner. So either there are certain type of the button or something like that that you can introduce on your these what you can say the search engine, the like that where the clients they can have that this type of the data I require and in which form, so that data can be customized in that manner, or either we have to get just data that is available from there in that particular form.
Yeah, for instance, in Japan, we have not a regulation. We are started, that deploy the mandate. So in case of the research data, especially focusing on the evidence data of the, the research journal, a paper has to be open as much as possible and immediate open. So by using the institutional repository or some specific, the domain data service, but have to be reported to the government if the researcher got the funded the budget from the publicly funded the funding agency. So we're gonna start from that one by one. But answering to your second question, we don't have such a the customizable the data negotiation or the one by one collaboration platform. But sometimes that people said this is the things we need. Otherwise the data is something the slightly different I need. So maybe we also has to have such a kind of the market style the platform, but right now we don't have it. So what about the situation in Korea or China? Do you have any answer, or you can share your experience?
Okay, I'm Jong On, who is managing data on service. We are in South Korea. We have data management schema and referring from data sites, DCAT, doubling core, and existed data, referring from the existed data standardizations. And we also gathering the some many field of research data. So sometimes there's no regularization and standardizations. At that time, we give some specific attributes for the each field of metadata, managing the metadata. So we call it attributes for special attributes, characteristic attributes. So by using this kind of attributes, they represent their own field of data. For example, space and geospatial data, and we deal with kind of this special elements for this. So and we are now discussing about a new standardization for aggregating metadata and data representation. It has to consist and continue about metadata schema for the data standardization in Korea. Thank you.
Yes, please, Eugene.
Yeah. So here, in China, according to what I know, I think there's not a national mandate about it, but different agencies like SFC or most, they have their requirement about data submission, like the key research projects and like the National Basic Research Center. If they have, because we host the National Basic Science Research Center, and if they have a domain center to submit their data, they will submit it to the domain center. But if they don't have an appropriate domain centers, they will submit the data to the National Basic Science Data Center. So our colleagues from there, they have a lot of those have interaction with the research teams. I think that one problem, one challenge is, as I mentioned, many of these research teams, they are very busy. Some of them will just submit like a spreadsheet, and data quality is, I think, is one issue about it, but is required. They need to submit the data, and including those type of description to the funding agencies through submitting that data to the data centers. And we also host the General Center of the Chinese Academy of Sciences, and that's different. And the about CAS is we have some type of develop some help the headquarters to develop some type of standards, like the recommendations for CAS data centers. And they also have evaluations, like evaluate the data qualities of different data centers, and to develop some type of tools for those data centers to work together. So I think perhaps within CAS is like more structured, because there is a division at the headquarters of Chinese Academy of Sciences to advise, have some advices to those data centers. And many of those, some of those data centers also support the national domain centers. Actually, I think among the 20 of the country, 11 national centers are hosted by the Chinese Academy of Sciences. Another one is the data that is data related to publication, and that's different. Like our scientific data bank, they support the submission of those type of data is similar. Like the administration in China here, they will have a type of announcement. It's like we is suggested that you better submit your data to scientific data bank. They have lots of data resources related to the publication. So I can say it is required, but not is not the national mandate, but required by different administrations related to data production here in China, I think.
Okay, thank you.
So this time we've started, the general update from the China, South Korea, and Japan, and we're gonna, extend one by one. Of course, we need from the ARDC, and maybe the Malaysia can, and Indonesia, and Thailand, and also Pakistan could be, the applicants. So send the appropriate person to this, working groups. So maybe the Marcus, please find a good person for who can, introduce ARDC update, twice a year, and also Chai. So you can do it from the Thailand. So maybe now from the next the APAN, next Tokyo. So we're gonna extend this working group. So expect and maybe
Tokyo.
Yes, please.
Yokohama.
Yokohama, yeah, that's Yokohama. So, but anyway, this time was the general, the update. But we can focus on the one specific, the area, or we can do it this kind of, that general talk. So let's keep in, the talk about it, our direction by the mailing list, or the follow up, the teleconference.
Anyway, we have a like 20-minute break, and we come back.
And same link,
Yes, same link.
different link,
Same link.
same link.
Just stay in
Okay.
the link. It's fine.